Okay, we are now in topic 10, second last topic, DC circuit. We are now doing paper 2, and we are going into different possible type of question you will encounter lah. Right? So hope you have done your homework. Don't hope to don't repeat lah. So that's what I'm trying to say. Try to put the extra effort there. AS score as high as possible because A2 you don't have much time. Half a year to study, less than half a year, and you have to prepare for. If you repeat AS, you have to do two together. So it's not easy to do that. So it's better to score as high as possible. If you want A and B, you have to put in the effort. Okay,
Mm.
we are now on question 116. Right? These are possible question. It's an old question, but it's okay. A student has available some resistors, each of 100 ohm. Draw circuit diagram, one in each case, to show how a number of these resistors may be connected to produce a combined resistance of 200 ohm. How will you get 200 ohm? Can
Just two resistor in series.
combine in series,
50 ohm combined in parallel.
combine in series, that's all. 100 ohm each, add it up is 200 ohm. No? How about get 50 ohm?
Parallel.
Parallel. How about 40 ohm?
Um. Oh,
For what?
I'm not sure about this one.
This one is a bit more difficult. The first two is usually easy. After that, it becomes more difficult. Combine them that way, parallel.
Oh, okay.
Two in series, and then all in parallel. Okay, the arrangement of resistors shown in figure 8.1 is connected to a battery. The power dissipated in 100 ohm resistor is 0.81 watt. Calculate the current in the circuit. What formula to use?
E equals IV, I square R.
Okay, good. That's all. Usually the first question is easy. After that, it's become more challenging. Then calculate your I. Power dissipated in each of the 25 ohm resistors. Right? You calculate the current. So how are you going to do that? Yep.
Also P equals I square R, right?
Say again.
P equals I square R.
How to do that?
Uh, for R, you substitute the resistance of those two. Oh, in each. So it's just one only. Yeah.
Yeah. How to do that? You can find the resultant resistor, but how do you find that? What current do you use? right? The current in each of them is half of this one, because they are the same, right? And power dissipated in each of them, I square R, correct? Then
Teacher, why are they the same?
you want one of them only, not two of them.
Oh, but
So you find the current through here, which is half of this one, because both of them,
both of them combined, how come it's same as the 100 ohms current?
current is divide this by 2, because both of them are the same resistance. So both of the current are the same. That's why we divide by 2. Then we want to find power dissipated in either one of them. So it's I square R.
Oh, but I thought 0.09 is for 100 ohms only.
Yeah, but when it comes to this parallel resistance, it branch into 2. So each of them will be half of this one. Okay now.
Oh, okay.
Okay, let's try something else. A filament lamp operates normally at potential difference of 6 volt. The variation with PdV of current in the lamp is shown. Okay, that's the curve shown you. Use figure 5.1 to determine for this lamp the resistance when it is operating at a PD of 6 volt. Yeah. How to do that?
Wait, 1600.
Right? Read from the graph
Hey, no, 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 no. No, oh, yeah, yeah, yeah. Wait.
and use IR. Right? Current
100,
is
150 ohm.
40 milliampere, so convert it to ampere, 150 ohm. The change in resistance when the PD increases from 6 volt to 8 volt. Right? 6 volt, we have calculated the resistance. 8 volt, 8 volt, that's your 8 volt. Current is
It
50
was 50, so it's 10.
milliampere. So calculate out 160. So subtract, change resistance. This one subtract that 10 ohm. Okay.
Okay.
Don't be frightened to draw on the graph lah. Right? It will help you draw on the graph, then draw on the graph. Or use a ruler to help yourself. The lamp is connected into the circuit of figure 5.2. R is the resistance of resistance 20 ohm. The battery has an EMF E and negligible internal resistance. On figure 5.1, draw a line to show the variation with PdV of the current and resistor. Yep. How to do that? Let's try this formula. Resistance is 20 ohm. So you need 3 points. Right? It will be a straight line passing through origin. And put 20 milliampere into here. Calculate the potential difference. Put 40 milliampere into this equation. Calculate it and then draw the line. Can or not?
Yeah.
the same lamp passes through, the same current passes through lamp and R, right? Just to review with you, what is the picture, right? It's in series. They are very kind, they tell the same current passing through both of them. Okay, sorry. The question is here. Determine the EMF for the battery for the lamp to operate normally. You want to find this EMF, no internal resistance involved. So how are you going to do that? Okay. The same current passes through the lamp and R. So you are told already passing through the lamp is 40. So from there, you can read that 8 volt across the resistance, across R.
Mm.
And then from there, you can read from the graph 8 volt and then add them up together. Sum of EMF, right? So through the lamp is 6 volt, through R is 8 volt, so it's 14 volt. Okay,
Yeah.
okay, let's try something else. Let's try potential divider. The thermistor has a resistance of 3900 ohm at 0 degrees Celsius and 125 ohm at 30 degrees Celsius. The thermistor is connected in the circuit in figure 8.1 in order to monitor temperature changes. The battery of EMF 1.5 volt, negligible internal resistance, and voltmeter has infinite resistance. The voltmeter reads 1 volt at 0 degrees Celsius, show that the resistance of resistor R is, right? The resistor is 7800 ohm. How to do that?
I don't know how to do this one.
Right? You are given 1 volt here. So there must be 0.5 volt here. 0.5 volt, you can calculate
Yeah.
the current through the thermistor. Current through the thermistor is the same as current through R. Then you can calculate R, right? That one equals to potential difference across thermistor and across R. That's why it's written there. And this is 1.5, E is 1.5. Across the thermistor is 1.5 minus 1 is 0.5 volt. And find the current through both of them. Right? Through the thermistor, can calculate. Right? We've got 0.5 there. Then current is 3900 ohm. Okay. Then from there on, you can calculate your R. Right? Current through both of them the same. You don't have to worry about this one because it's high resistance. So VR is 1 volt. I will calculate that. R and using calculator. And
Yeah.
temperature of the thermistor is increased to 30 degrees Celsius. Determine the reading on the voltmeter. How to do that?
This one using scale, is it? Or is there a formula for
Show
it?
you the diagram there. It's a potential divider now. Right? R is given you in case you are wondering where I get it. Right? 30 degrees is 1250.
50.
Yep. Same. Calculate the current and calculate the PD across R. Or you can use the formula for potential divider. Right? V over the whole thing, 1.5, use proportion is 7800. Add the two together and calculate out. Okay now.
Oh, this one use the potential divider formula.
Potential divider formula, proportion. This one over the whole thing. This one is the sum of that. This one is V, voltmeter reading over the whole thing is 1.5. Or
Oh, what's the other way?
say again.
What's the other method?
Our method is just calculate the current through both of them. Then calculate the PD through
Oh, how
here.
do you calculate the current?
It's the same thing. The current through the circuit. Okay.
Okay.
If you don't want to memorize formula, find the current through the circuit. Right? The voltmeter is replaced with one having a resistance. Right? Calculate the reading on this voltmeter for thermistor at 0 degrees Celsius. Okay. How to do that now? Same thing. For the parallel resistor, replace it with one. No? And then find the PD across the parallel resistor. No? That's the voltmeter reading. No? Right? So combine them together. We divide by 2 because they are parallel. Divide by 2 is 39. Then take the proportion. No? Receive the voltage divided by the total EMF equals to 390. And add these two together, 390. Okay.
Oh, wait.
You don't want to memorize formula, use the basic formula. Calculate the current. Replace this one with one resistor, which is this one. Then find the current through both of them. No? Okay now.
Yeah.
One, two, two. Define resistance of a resistor. Yep. Define for me. All this must be in your head already by your
Uh,
fingertips.
can I say the ratio of voltage and current?
Potential difference across the resistor to current flowing through the resistor. right? Or just write the potential difference divided by current.
Ratio of potential difference and current can.
Can also, or just write the forward potential difference over current. The circuit in figure, the battery has an EMF, is written at 3 volt, internal resistance R, and R is a variable resistor. The resistor ammeter is negligible, so I don't have to worry about the ammeter. I just read the current through R, that's all. And the voltmeter has infinite resistance, so you don't have to worry about resistance there. The voltmeter just read the voltage across that one there. Okay, so that this graph you have to memorize. The resistance R is varied. Figure 7.2 shows the variation of the power dissipated in R with the potential difference across R. Right, here's the graph. On figure 7.2, use figure 7.2, that's here 7.2, to determine the maximum power dissipated in R. Right? It's just to test your reading skill, that's all. Right? Maximum power is here. Right? Maximum power, just read on. When you draw a line there, then read 1.13. Potential difference, read the graph, potential difference, 1.50. Hence, calculate the resistance R when maximum power is dissipated. Can, what formula to use?
Maximum power, I square R.
That's all. I square is not given. How to find a current?
Uh,
You given
mm,
power, potential
yeah, then
difference.
reverse out throw power, square root power over uh potential difference.
Right? V square over R. Maximum power is there. You read, just read. V square, this one. Then calculate it. 1.99 ohm. Can.
Yeah.
Use your answer in 1 and 2 to determine the internal resistance of the battery. Okay, you got that 1 and 2. What's the internal resistance? How to determine the internal resistance? Right? Can either argue it out. Right? To find that one, you already got the potential difference across this R. So this is 1.5 here. This is also 1.5. So the both of them have the same resistance. Right? Or you want to work it out, EMF equals to I, this small r plus R, or V across here is V. And then you know that PD across R equals PD across R, small r. Then put in your value into that equation. That's if you want to calculate, it's about 2 ohm. Or argue it out. Right? 1.5 here is 3 volts, so 1.5 across here. So the two resistance must be the same. Okay,
Yeah.
by reference to figure 7.2, it can be seen that there are two values of potential difference V for which the power dissipation is 1.05. Right? 1.05 is around here, somewhere around here. State with reason which value V will result in less power being dissipated in the internal resistance. Yep.
What does it mean by which value of V?
There, you got 105 around here. You got
Uh-huh.
two value of R, two value of V. So they want which value will give the energy dissipated in this R the smallest. R is larger. Right? This R is larger than R, a larger PD. That's a larger PD. Means smaller PD. Right? Basically, these two are sharing. These two are potential divider. More greater resistance here, greater PD across here, less PD across here. So
Oh.
power dissipated is P equals to VI. Right? That's what they're saying. R is larger. Smaller power dissipated in R at larger value of V. Since power is VI, I is the same for R and V. Okay now? The current is the same.
Yep.
Okay, let's try something else. Okay, let's try this one. Number 2126. Right? It's shown in the diagram there. Right? He's charging a battery. The current in the circuit is 42 ampere, and the EMF of battery is E, measured in volts. What's the magnitude of total resistance? Yep. This is a series circuit. So total internal resistance, total resistance is just add up. This one plus that one. Yep. Total EMF,
Oh.
give your answer in terms of E. Yep. So you are charging battery, usually the current must flow from here clockwise. So this one will send current anti-clockwise. So you subtract using Kirchhoff's voltage law, 14 minus E. Right? This one send the current clockwise. So it's positive. This one carrying the current anti-clockwise. So minus. Okay.
Yeah.
Use your answer in one and data from the question to determine the EMF of the
Okay.
car battery at the beginning of the recharging process. There's a picture. What is given?
Teacher.
So how to calculate
Teacher.
the EMF? E.
Teacher.
Yep.
Teacher. Just now
So
you
again,
took 14 minus E, right?
just using the applying Kirchhoff's voltage law, 14 minus E, right? That's a total EMF equals the total PD. PD is the current times the total resistance. These two add together. That's why I get that. Then calculate your E.
Teacher.
For
Teacher.
majority of the charging time, the car battery, the EMF, the car battery is 12 volt and the charging current is 12.5 ampere. The battery is charged.
Teacher.
Yeah.
14
Anything?
minus E is because uh It's
This
moving.
one is charging battery, right? This one show you positive, so the current is
Yeah.
flowing from positive. So you choose that as a positive direction. But this one, the positive is here. It send the current anti-clockwise. So that's why you subtract wrong. Yep. If it's in the same direction, you add on.
Or is it because E is traveling anti-clockwise and 14 is
One
traveling
is clockwise, the other one is
clockwise?
anti-clockwise.
Oh, okay.
So you choose clockwise as positive, then anti-clockwise must be negative. Lor.
Then was the current given as 42?
The current is given in the beginning of the there.
Oh, okay, okay. Yeah, that's all.
The charge that passes through the battery. How to calculate the charge passes through the battery? This one is playing with all the formula, that's all.
Charge is Q, is it?
Right? Charge is IQ, current times T, right? Current yeah, total is 12.5. 4 hours, changes to second, 60 times 60, change to minute times 60 times the seconds times 60 to get your answer.
Right.
Okay,
Yeah.
right? That's what we have calculated so far. Energy supply from the battery charger. Yep, what to do? V times I, no? Oh, sorry, E times Q. V times I is power. So E times Q, no? Battery supply to battery charger. This one. Right? E times Q. So we call that ES. ES supply, energy supply. E is 14. Q we have just calculated. Okay, now
Yeah.
total energy dissipated in the internal resistance of the battery charger and the car battery. Right? We got the current, we got a total resistance, and use I square R. I square R times T. Can time we convert it to second, that's why we times 3,600. Okay or not? I is 12.5. R is the total resistance of these two. That's your R. Okay.
Okay.
Use the answer in B to calculate the percentage efficiency of transfer energy from battery charger to store energy in the car battery. Right? And minus the energy supply and energy dissipated or energy supply. Right? That's what we have calculated before. And times 100%, it's 86%. No? Okay.
Yep.
Okay. 132. calculate the resistance of the lamp at its working temperature. Memorize formula only, this one. Straightforward. How to calculate the resistance of the lamp?
12 square over 36.
I square R. Then R is V square over P, cross multiply. These two, cross multiply. 12 volt square over 36 is 4 ohm. On the axis of figure 6.1, sketch the graph to show the current voltage characteristic of the lamp. Mark an appropriate scale for the current on the axis. Right? We have calculated already the current, potential difference, 12 volt. There's a point there. Then the others is memory work. Oh. Okay, now that's how we calculate our current.
Yeah.
Heater have constant resistance. Determine the total power dissipated for the heater connected as shown in each of the diagram shown below. Yep. This one you don't have to show working. If you want, you memorize it. Oh. What's the answer? Same voltage across each of them. So same power dissipated. Lo. So you add the two together. Lo. Okay now. Right? You are told that the heater have constant resistance. Okay, how about this one? All dissipated. When the heater is in series. Okay, calculate your I.
Yeah.
Calculate your R. R is V square over P. P is that one there. Right? Voltage is 230. So total resistance. Right? This resistance across this one. So it's just half. Lo. Okay now.
Yeah.
First, from this information given, calculate the resistance of the each lamp. Right? Resistance is constant for each of them, the same. And total resistance is that. And from there, if not memorize it, lo. How about for one of them? Right? Or you can use current, lo. Half the current flow through that. Okay, there's alternative way of calculating. Same thing. Okay,
Yeah.
now it's a bit difficult lah. That one you will be cut off lah. So you have to try it during the break. Try the other question that I've given you lah.